Alright, hello folks, my name's Kit. Today I'll be going over my solution for the Advent of Coding 2022 challenge, day number 18. When implementing this, the way that I modeled each cube was I would have a cube and then the XYZ point would correspond to this point right here. And so for part 1, the algorithm is pretty simple. We iterate through each cube and then we count the number of sides that do not have a cube beside it. So I iterate through each line of the input and then I would convert it into data model, which is just a cube, which is an alias of a tuple. And then I created this new class called CubeWorld, which encompasses all of the logic that I need in order to calculate this problem. For the first part, we want to count the number of total exposed sides. So we iterate through each cube, then we do a summation of all the exposed sides. The way this function works is that we would iterate through all of the offsets. The offsets are basically, we're at point XYZ. The point at the right would be x plus 1, yz. The cube at the left would be x minus 1, yz. And then so forth and so forth. The way that I implemented was like this. So here we have the x offsets, the y offsets here, and then the z offsets here. So back to this function, what we would do is we would iterate through all of these offsets, and then we would check whether or not there exists a cube there. And if it doesn't, then we count that side. That is basically it for part 1. For part 2, what we're trying to do is count the number of enclosed air cubes. For example, if we have something like this in the 2D realm, we basically want to count the number of cubes that are enclosed from all sides. Now, there is something that makes this a bit more difficult, which is that there can be these tunnels in the cube. So for example, here we see that this air cube is actually still exposed externally because there is a path from here all the way outside. This air cube wouldn't count as being one that is enclosed from all sides. The way that I did this is that first I thought about just the world itself. So I thought about the width, height, depth of this imaginary boundary that encompasses the entirety of our obsidian shard. And then what I would do is I would just iterate through all the blocks in this specific region. But first, let's talk about the algorithm. So part 2 is this count exterior surface area. First thing that I do is I get the number of total exposed sides. And something you want to note here is that once we get the number of total exposed sides, what we can do to just get the exterior sides is that we can subtract the sides that are totally enclosed. For example, if we took a look at this cube here, we see that there are 3 sides that this air cube touches. We should subtract 3 from the overall total. In order to do this, first I would create a cache of the air cubes that can reach the outside. First, I would iterate through all the cubes in our world, and then I checked whether or not the cube that we're currently looking at is exposed to the outside. It's exposed to the outside. For example, if we first look at this cube here, imagine we're just in the 2D realm. I would look left and see whether or not it's enclosed. Then I would look right, then top, and then bottom. You would notice that if you go down, eventually you'll reach a point where you're outside of the little boundary that encompasses the obsidian shard. If that's the case, that means that you have a path outside. That algorithm doesn't really work for cubes that are really far into the shard, for example, this one. What we actually need is the ability to know that we are connected to other air cubes that are connected to the outside. So then what I did was I had a while loop that would cache all of these spots. The first pass, for example, would only see this cube and then this cube. And then the second pass would then see this cube and then see that is connected to a cube that is connected to the outside, and then it would add that into the cache. So then I would just keep on rerunning the algorithm until eventually all the air cubes are accounted for. Here is the algorithm that did this. So it's in the initialization So here I would store the previous cache size, and then while true, I would iterate through all of the cubes, and then if it's exposed to the outside, then I would add it to the cache. Then I check whether or not the cache size increased, and if it did, then it would keep running this loop. And if I notice that the cache doesn't change, then I break from this while loop, which tells me that we have found all of the error cubes that are exposed to the outside. Okay, so then back to the algorithm. What I would then do is iterate through all of the cubes in our boundary, and then I checked whether or not it's an enclosed error cube. So in order to know whether or not cube at this position is an error cube, there are a few conditions that need to be met. First, there can't be a cube at that current position, so if there is, then it's not an error cube, it's a solid cube. So we return false. If the error cube is exposed to the outside, this here, if it's exposed to the outside, then that means that it is not enclosed. So then we return false. Then afterwards, we just iterate through all of the offsets and make sure that all sides are encompassed by a cube. Then that is basically the algorithm for this. And then, so if it is an enclosed error cube, then I add it to this list, and then I return this list. Then once we get all of the enclosed error cubes, what we do is we count the number of sides that are enclosed. This would just be the inverse of the number of exposed sides. For example, if we have one exposed side here, then there are 3 sides which are not exposed. So then we subtract those sides from the total. So we get the summation of all the enclosed sides, and then we subtract it by the number of exposed sides to get our exterior surface area. And this turns out to be pretty quickly because the boundary is actually not that much. If you look here, it's about a 23 by 23 by 23 cube. Yeah, the algorithm ran pretty quickly. That is basically my solution for day 18. Thanks for watching and have a great day.